One thing that we might want to do with pyprocg is get switch events. So the way that works is with get events here. Get events just returns an array of switch events. So like Gerry was talking about with the switch state changes. So you get a number and then a value that tells you, that describes that state change. So the switch has become closed, the switch has become open. But even cooler than that would be if we could affect some actual changes on the pinball machine. So we have here a command, a line of code here, P-ROC.driverPulse, and we pass it a number, 8, and milliseconds, 200. So we're going to pulse driver number 8, which could be a coil, it could be a flasher, whatever, it could be a lamp, for 200 milliseconds. And so you can see, and this is the way Python does some things where we have named parameters that make it pretty clear, we hope, what's actually going on here. And then lastly, I want to talk about two kind of important commands that point to some features that the P-ROC hardware has. One of them is the watchdog tickle. So the P-ROC has, if you're familiar with watchdogs, it has a watchdog circuit, and this watchdog circuit needs to be tickled once every second, I think. And essentially this is like a dead man switch. So if by some chance your software has some bugs in it and maybe it crashes, the P-ROC is going to notice that your software has gone away and it's going to cut off all your drivers. So this can save you a lot of fuses or having to file an insurance claim because your house burning down or something like that. And then the last command here is P-ROC.flush. Flush just sends all of the command data out to the P-ROC. And this is separate from driver pulse or watchdog tickle because those commands are really small. There's only a few bytes there, and it's really inefficient if we send out, little tiny bits of data over and over again. So we gang it all up and send it all out at once. In reality, we do that pretty quickly, but it helps to gang it up like that. So let's get to the meat of the conversation here, pyprocgame. So pyprocgame, as I mentioned before, is it's a rule set development framework. It's object-oriented, it's open source, it's available on GitHub right now. You can download it, you can modify it, you can fork it if you're familiar with all the Git stuff. And more than anything, it's a collection of classes that are built to work together to make it easier for you to write pinball software. And we wrote this as part of developing the Judge Dredd code. So we think that some pretty good. We're not going to pat ourselves on the back too much, but we think there's some good decisions in there which make it fun and relatively easy to write pinball software. And one thing I want to underscore before I move on is that even though all these classes are designed to work together, we've tried to make decisions in key places so that if you're not using a DMD on your custom game, like let's say you want to use an LCD, you could just not use the parts of the DMD stuff. You're not going to be stepping over potholes where you're not using the DMD code. But before we get to some actual code for pyprocgame, I need to talk about something important. These are machine configuration files. Machine configuration file is a YAML file, which you may be familiar with. It's a plain text, it's not markup language, but it's a plain text file format that's a configuration file. So you can see we've got a section here that describes the game, and we describe the machine type that ties into that pinproc call that we saw before, and that sets up the defaults, define the number of balls. We're also going to define some switches here. Of course, in a real game there'd be dozens of these, but the slide's only so large. So we have lower left flipper information, saucer information. One thing that you can define here that's really helpful, you may know that mechanical switches and optos work differently. Optos are normally closed, I believe, and mechanical switches are normally open. So you can code that information here, and then within pyprocgame refer to switches as active or inactive, which indicates whether the ball is there or the ball is not there. So you don't have to think about whether the switch is an opto or not. We're going to define some coils. And the whole idea here is we're assigning a name to a number, essentially, so that your code becomes more readable. As you'll see, and it's you're not doing something like in that earlier slide where you're pulsing coil 8. You're only going to remember what coil number 8 is for, well, maybe longer than I'm giving you credit for, but It's going to be hard, so you're not going to want to do it. And then maybe most interesting about this slide, so we have these sections, flippers and bumpers. And you'll notice that the names here, for the flipper lower left anyway, match up with the other names. So the pyprocgame software looks at the machine configuration file and sees, oh, you're defining flippers. Well, I know how to configure a pretty good switch rule set, like Gerry was talking about, to make the flippers work. And so it can do that for you, so you don't have to, basically these are things that we did to make it so that you can ramp up very easily and you don't have to have a whole bunch of boilerplate code in your game to make it work. Okay, so actual classes. There's two really key ones. The first one is game controller. The game controller, there's only going to be one, and that refers to your actual game. It's kind of the object that controls everything. And it also does something interesting, which is it makes that get events call. So it gets the switch events, and then it sends them out to all of your mode classes. So you're going to be subclassing game controller and mode separately, of course, and so the mode subclasses are going to be what actually register for switch events and receive those switch events from the game controller. So let's look at what all is contained in the game controller. We have some game data, so the set of the current set of players that are playing, machine configuration file, so just basic state information about what's going on in the game. We have what we call game items, so these are all the physical components of the game, so switch, coil, lamp, well, plural of all those, which you would refer to by name using the YAML file that we talked about before. We also have the mode queue, which is a collection of modes, and they are organized in a priority queue. And the reason this is important is because you can set a priority on the mode that indicates this mode should receive switch events before lower priority modes. And you might be able to imagine how that would be helpful in designing a game. And then finally we have the run loop, which is what I referred to earlier a little bit, which gets the switch events, hands them off to the mode queue to be processed, and then flushes the buffer into the launch door. Crystal clear? Good. Okay. So, I just want to summarize on the notes here, because they are really pretty important. Once again, modes are logical subsets of game functionality. Really, and I should underscore this also. If you're a pinball player, you think of modes as like Mamushka or Lost in the Zone. That's a pretty huge mode, right? Modes to players are very, very high-level concepts. In pyprocgame, modes can be whatever layer is appropriate to. Whatever level of complexity is, and it is kind of up to you to decide how you want to organize your modes. So you may make modes that, as we'll see in a second here, are very, very simple. They're just focused on, operating one piece of hardware, like a drop target bank or something. Okay, so let's look at what a simple saucer mode would look like. So we're going to define a new subclass of mode here. It's called simple saucer. And if you're not familiar with Python, or just kind of bear with me, I think this might still make some sense. And then we're going to define a switch handler so we can actually make the saucer do something. And so the switch handler name here is SW for switch, saucer, active. And hopefully that's kind of clear what this is saying. This is saying that for the switch named saucer, whenever that switch becomes active, call this method and make something happen. And the way this actually works is when your mode is created, we use some of those introspection features of Python to look through the class's modes, see what all their names are,